Okay. Can I start? A very good morning to all participants. Hi, this is Jaswinder from SWA. Welcome to today's webinar co-organized by SWA and Pioneer Environmental Technology Private Limited. Before we get started, I would like to take a moment to go over on the following. Housekeeping. To ensure a smooth session, please mute your microphone and turn off the camera. You may communicate with us after the event. Please share your questions in the chat where we can try to provide answers where possible in the Q&A segment. Do identify yourself so we can respond to any unanswered questions. We will be recording this session and reserve the rights to the video. Please complete a post-event survey, which upon return, we will forward the recording and presentation deck to the respondents. Disclaimer: all information shared is for general information only and does not contain or convey any legal advice or administrative assistance. Information shared today is true and accurate as of publication date. SWA and Pioneer Environmental Technology Private Limited reserve all rights in the provided material. Lastly, do participate in the post-survey which we'll be sending to you after this webinar. As much appreciated your feedback on how we can always do better. Now, without further ado, I would like to invite Mr. James Ow PBM, Executive Chairman cum CEO of Ann Aik Limited. Mr. James Ow founded Ann Aik in 1977. In 2003, Ann Aik was listed on Stock Exchange of Singapore. Mr. Ow works closely with Singapore government leaders to actively promote grassroots organizations as well as Singapore Chinese investments. Through his social trade networks with Chinese professional organizations and Chinese community leaders, Mr. Ow supports Singapore trade development and relations with the world. He was awarded the Singapore Service Medal by the President during the prestigious National Day Award ceremony for having rendered commendable public service in Singapore. Now, over to you, Mr. James Ow.
Thank you, Jaswinder. Thank you, dear Vivian and Singapore Water Association team for co-organizing and planning this webinar with Pioneer Environmental Technology Private Limited. It is my honor to attend this webinar and have the welcome address. Welcome everyone here and wish you all will enjoy the webinar. Singapore-China Business Association, in short SCBA, is a non-profit organization which founded in 1970. Currently, it has around 500 corporate members and actively act as the platform to promote and strengthen the business activity for both countries. SCBA arranged multiple annual mission trips for each member company in Singapore to visit China in order to explore for potential business opportunity. Similarly, we also act as a host for China company or government officers when they come to Singapore for business trip. As we know, the environmental control and awareness in China is continuously improving, especially in the last decade. We believe that this trend in green and sustainable environmental concept in China will be one of the key strategies in its business development going forward. With more corporate members in SCBA are involved in environmental business or provide its proprietary technology in market, I hope both the SWA and SCBA can work closely and jointly promote business activity in Singapore or China, especially for water-related environmental business. Today, I'm happy to see the Pioneer Environmental Technology would like to share their experience and technology with you all on the treatment of industrial wastewater and zero liquid discharge. I wish the webinar will be successful and fruitful. Let's start the webinar. Thank you. To you. Yeah, you haven't mute. You are mute. Can't hear you. Jasminda, you did not unmute.
Okay.
Okay.
Thank you. Thank you. Thank you very much for the welcome address, Mr. James Ow. Okay. Now it gives me the pleasure to invite our keynote speaker for today, Dr. Raymond Yang. Dr. Yang holds a doctorate degree in philosophy chemistry from NUS, Master of Science Chemistry from Shanghai Institute of Organic Chemistry, Chinese Academy of Science and Bachelor of Science Chemistry from Wuhan University, China. Dr. Raymond joined Ann Aik in May 2005. Currently, he is the General Manager / Director of Pioneer Environmental Technology Private Limited. Dr. Yang has published more than 10 articles in the top scientific international journals, holding several patents in the environmental management field. Over to you, Dr. Raymond Yang.
Good morning, everyone. This is Raymond Yang from Pioneer Environmental Technology. Thank you, Vivian, Jasminda, and the SWA team for organizing and planning this webinar. Thank you, Mr. Ow, for the welcome address. Today, I would like to share with everyone about our experience in industrial wastewater treatment, particularly in pharmaceutical wastewater treatment. So this is the content for our today's webinar. Next slide, please, Jasminda. Introduction, yeah. As we know, Singapore industry is fast growing, and particularly for the pharmaceutical industry after COVID-19. And 8 of the top 10 pharmaceutical companies have facilities in Singapore, manufacturing 4 of the top 10 drugs by global revenue. And worldwide, big players like GSK, MSC, Novartis, all these are in Singapore. Next slide, please. And from the website, you can easily search that pharmaceutical industry plays more and more important roles in Singapore. Next, please. And while the pharmaceutical industry is growing, and it is also generating more and more hazardous waste, particularly from production of API, active pharmaceutical ingredients. And among the hazardous waste, the most difficult to treat wastewater is, we call it SFOR high, the wastewater with high COD, high salt, high volatile, and high toxic organic. And conventionally, all this kind of wastewater is incinerated. But because of the low heat value of this wastewater, and the incineration cost is very high because of the additional fuel is needed, and also because of the high hot salt content, when it is incinerated, generated the choking problem and increase the maintenance cost for the incinerator. And currently, the wastewater price in the Singapore market about Singapore dollar 300 per ton, and which is increasing, and the cost is higher and higher. And of course, many people say that how about the biological treatment? Of course, biological treatment is very attractive due to its low cost, but how about the toxic ingredient and the high salt? All this will harm the bacteria and difficult for the bacteria to survive. Next slide, please. Okay, these are the examples of the API, active pharmaceutical ingredient, and these are all these toxic bacteria for the bacteria. You can see from the formula that this contains the fluoride, chloride, sulfur. All these are the toxic element to the bacteria, and very difficult for the bacteria to digest. Next slide, please. Okay, let's take a look at the conventional wastewater treatment process. Conventionally, of course, the customer needed to do the clean production waste minimization, and no new synthesis method or this on-site waste management, treatment, recycling, all done by the customers. So after all this from the production, generate the wastewater, so go to the wastewater treatment. And basically, the wastewater treatment, we have three parts. First part is the wastewater pre-treatment, and after the pre-treatment includes the screening, oil grease removal, stripping, evaporation, physical chemical treatment, LP. LP stands for advanced oxidation process. And after that, the wastewater go to the biological treatment, and which usually have the anaerobic and aerobic process, and include USB, MBBR, MBR. And after the biological treatment, now because of more and more stringent requirement from the environment and the government, so the wastewater, we usually also go for the post-treatment. We call the polishing or recycling. And this technology includes the LP, adsorption, ion exchange, and UF and RO. Okay, then we go back to the pharmaceutical wastewater wastewater. How about the high COD, high salt, high volatile, and high toxic organic, this kind of wastewater? How to do the pre-treatment? Next slide, please. Okay, we focus on the pre-treatment on two technologies, the stripping column and the Nvr. Next slide, please. Okay, we developed the technology for the integrated wastewater treatment, and we have this stripping column and the Nvr combination. So let's take a look at what is the stripping column. Stripping process is use little energy to remove the volatile organic compound VOCs from the wastewater, and the concentrated VOC, usually as a solvent, can be used or inserted. So it can also be recycled in some time if the stream is a single stream. And okay, then what is the Nvr? Nvr stands for mechanical vapor recompression, which is a proven technology with energy saving, and the evaporation process we understand is a very good separation technology for solid and liquid. So Nvr uses secondary steam to reuse the secondary steam, and the energy is recovered and reused. That's why the Nvr process can have the energy saving function. Next slide, please. Okay, now we talk about the stripping column and Nvr. So why stripping column and Nvr? So in principle, there are only two types of COD, basically. So it's a volatile and a non-volatile. So if we remove the volatile COD by the stripping column, and the non-volatile organic by the evaporation process, so in principle, all the COD can be removed. Of course, this is a quite interesting question, is that after stripping column and Nvr, what is the COD left? So in principle, no COD left, but in practical, there's still some COD left. I will elaborate later. Yeah. So in this, of course, just now mentioned that most of the organics can be removed. Yeah. But to a certain which extent is quite difficult to say at now. Only to test by the actual performance. So after these two processes, then the wastewater we call it purified wastewater, can be treated by PC treatment or biological process, because it is detoxified already. Yeah. Next slide, please. Okay, this is the patent, the technology we registered in China. Is the invention patent. Next slide, please. Okay, so with this patent technology, the 84 height wastewater can be treated. So this technology is, in general, I will elaborate later on this part. It's the non-specific, yeah, not like LOP. LOP sometimes it works, sometimes doesn't work. Yeah, but this technology works for every kind of industrial wastewater. Basically, the pharmaceutical wastewater. Yeah. Next slide, please. Okay, this is a stripping column we set up for hazardous waste management company in Singapore, which is the largest in Singapore and also the largest, most advanced in Southeast Asia. And we set up this stripping column 10 years ago, and it is still in operation. Yeah. Next slide, please. Okay, so this is the stripping column, the process, and we can see that from the left side is the column, and from the top side, the wastewater is injected into the column, and from the bottom part, the steam injected. So inside of the column, the steam transfers the energy to the heat to the wastewater, and the VOC, volatile organic compound, basically the solvent is evaporated and condensed and the collected, sometimes recycled. And after the stripping column, the stripped wastewater contains very little VOC. Next slide, please. Okay, so how much VOC left? So this is also another interesting question. So before we set up the stripping column for the hazardous waste management center, actually we have no answer for this. So after we set up and ran for several months, we found that the efficiency is very high. So from a few hundred ppm VOC reduced to less than 10 ppm VOC. Next slide, please. Okay, now we talk about the mechanical vapor recompression, Nvr process. So why Nvr? Basically, we want to save the energy. So conventional wastewater treatment, the evaporation, after evaporation, the steam is condensed by the cooling tower water. And by the cooling tower water, the energy released to the air. Actually, all this energy is wasted. But in the Nvr process, the vapor after evaporation is compressed by the compressor, which uses electricity to increase the steam pressure and the steam temperature. So with this increased the temperature and the pressure in the steam, this steam can be reused again. Yeah, you can see from the picture is that the red color is the vapor after the Nvr compressor, then the pressure temperature increase, then go to the heat exchanger again. So in this way, the heat can be transferred to the wastewater again. So that's why the energy is recycled. And interesting now, in large plant, the energy consumption is about 10 kilowatt for evaporation of 1 cubic meter per hour. And this is very attractive already, because in Singapore, if the 1 kilowatt hour, the cost is Singapore dollar 14 cents, for example. So it's about 1.4 Singapore dollar for 1 cubic meter of fresh water, and this is almost comparable to the hour cost for the hour already. Yeah, and for the small plant, the energy consumption is a bit higher. Small plant, I mean that about evaporation about 2 cubic meter per hour. The small plant. Yeah, so This is about 50 kilowatt per hour. But this cost is still very attractive because in terms of electricity, it's about less than 10 Singapore dollar to cost to evaporate 1 cubic meter of water. Yeah. Next slide, please. Okay, this is a 3D model for the Nvr system. Yeah. When we design, we usually use a 3D model. Yeah. Next slide, please. Okay, so this is the integrated column and stripping column and Nvr process. So from the left to the right side, the left side you can see the wastewater injected into the column, and the bottom the steam injected. After the stripping column, the wastewater is go to the Nvr process, and the Nvr after evaporation, the steam. The right side, you can see that the Nvr compressor compress the secondary steam and increase the temperature and the pressure, so transfer the energy to the wastewater again. So the energy is recycled, and the steam itself becomes the distilled water in the blue color you can see. Next slide, please. Okay, this is our first stripping column and Nvr system built in China, in Jiangxi province, in the center of China. It is already operated for more than 5 years. And okay, this is the actual picture. Next slide, please. Okay, another actual picture of the plant. In the right side, you can see that the two column, which is a heat exchanger. So the wastewater is in recycled, circulated inside, and circulated inside, and out the steam is have the heat exchanger in these two chambers. Next slide, please. Okay, this is the control system, the HMI for the Nvr. Then the whole system can be operated on the one person. Yeah. Next slide, please. Okay, this is the stripping column process. Also the HMI control system. Next slide, please. Okay, just now we mentioned that the COD is either volatile or non-volatile. Okay, then the one question is that after stripping column and Nvr, what is the COD level? Yeah. So in principle, all the COD can be removed, right? But in the actual performance, it's not so ideal. So we found that the COD, input COD, for example, 30,000 to 50,000, then after this stripping column Nvr, the COD around 5,000. So this is a very interesting finding, is that actually regardless of the input, we always get the distilled water, the COD around 5,000 ppm. Next slide, please. So this is the confidence when we talk with our customer, is that we just see what kind of solvent inside, what kind of the residue inside. Okay, we will have the proposal for you. Sometimes people, they whether needed to do the lab test or this. Actually, we also have the findings from other plants. That's why we have the confidence sometimes. So say, okay, no need a lab test. Yeah. So you can see that the CO from this in the red color, the box, the original wastewater is 140,000. Yeah. So after the stripping column part, the top part, VOC part, is 350,000. Yeah. So then the middle part, very interesting, is that only few thousand, sometimes less than 1,000. And the bottom part, you can see that again is almost 500,000 COD. So that's to say that in this wastewater, we remove the volatile and the non-volatile. So most of the COD is removed. So actually, in this wastewater, even no need a biological treatment, just one LP can meet the discharge limit of 500 ppm already. Yeah. So this is different from the LP that this technology is universal. Next slide, please. Okay, now with the effective pre-treatment, now we're very comfortable to treat the wastewater with a biological method. Yeah. Next slide, please. Okay, this is a whole biological treatment plant in China, in a pharmaceutical company, in a single pharmaceutical company. It's not in a waste management center. So it's quite big. Next slide, please. The side view of the plant is a wastewater plant. Yeah, it's not the chemical plant. Yeah. Next slide, please. Okay, so even we have this the pre-treatment of stripping column, we still have some small toxic material left. So we use a micro-electrolysis to detoxify. This micro-electrolysis process is quite interesting, but I will not elaborate on in this presentation. You may check the website here. It's quite popular in China, and actually now become a standard process for the chemical wastewater treatment for this micro-electrolysis. Next slide, please. Okay, then good after this microelectrolysis, then to go to the anaerobic process. These are conventional anaerobic process. Next slide, please. And we also employed the NVR for our aerobic process. Next slide, please. Aerobic tank, NVR. We can combine the NVR and the NVR together. And in the NVR process, we use a PTFE membrane. Because in this pharmaceutical wastewater, although we have gone through all this pre-treatment, there's still some residual chemical left. Next slide, please. Okay, these are the piping work for the wastewater treatment plant. Actually, this wastewater treatment plant in Hangzhou, and actually is near reservoir. Yeah. It's very stringent. Yeah. Next slide, please. Okay. Chemical dosing system. Next slide, please. Air blower and filter press for sludge dewater process. And this online monitoring. Okay, so this is also interesting in China is that every pharmaceutical wastewater, every pharmaceutical company, the wastewater have to install the COD online, nitrogen, phosphorus, or this. This is the controls then the data will submit to the government, so monitoring. So you can see that the COD is less than 100. So the requirement is less than 200. Next slide, please. Okay, so up to now, we have the pre-treatment and the biological treatment. So we have this integrated technology for pharmaceutical wastewater treatment. It's stripping column plus NVR to remove the volatile and the non-volatile organics and the salt. And then this the micro-electrolysis to detoxify further of the residual chemicals. Then the aerobic process and anaerobic process and the aerobic NVR PTFE membrane. So this is the treatment process. to meet the discharge to discharge limit regulations. Then after a while, I will talk about a bit about zero liquid discharge. Zero liquid discharge, that means that the whole wastewater can be recycled. Yeah, no, almost no discharge. Next slide, please. Okay, just now I mentioned that this wastewater, the pharmaceutical wastewater, is near a reservoir in the upstream of Hangzhou City. Yeah, the control is very stringent. So, but you can see the input, the COD more than 50, nitrogen, ammonia, nitrogen 200, total nitrogen 400, TDS more than 20,000. So all this wastewater, if not treated properly, have to go for the incineration process, which is very costly. Next slide, please. Okay, then this is our output. We achieved COD less than 100 ppm, and ammonia nitrogen less than 25, total nitrogen at 40, TDS less than 1,000. Yeah. So after this treatment, then this wastewater will channeled to the centralized wastewater treatment in the chemical industrial park. Then meet the standard A, at least standard A. That means COD less than 50 ppm. Now the requirement is more to meet the surface water, the COD less than 30 ppm. In order to discharge for the centralized industrial park wastewater plant. Next slide, please. So far, we have completed 3 plants in China, and we have more than 20 projects in discussion, and actually all this project in all over China. Yeah, some in even very in the Mongolia, Xinjiang, or this very far. But most of our customer in near Shanghai area, Jiangsu, Zhejiang province. Next slide, please. Okay, now I move to the zero liquid discharge section. While the technology was developed in China, we have also started to apply it in the local market. Next slide, please. Okay, this you can see that this is the largest, actually, to our knowledge, this is the largest NVR in Singapore. The left side is the heat exchanger, right side is the evaporator, which is a crystallization tank, we also call. Yeah. Next slide, please. So it is in installation. It is also installed in a hazardous waste management company in Singapore. Next slide, please. So the system is completed, testing committee completed and operated in for more than 3 months already. So this is the pump station. Next slide, please. And the right side is the heart of the NVR, which is a compressor. And the left side, you can see that one is the evaporator and another is the heat exchanger. You can see the heat exchanger design is a little funny, it's very short, because this plant have the civil work already completed. So we have to design the whole system according to the civil work. So the space is very limited. You can see it's very challenging to build this plant. Next slide, please. Okay, so these are the more example, 25 tons per hour, MEG, multi-evaporator, multi-effect, multi-effect evaporator in China. Next slide, please. So another MVE, multi-effect evaporator, 50 tons per hour. Next. Okay, this is a big NVR. This is 62.5 tons per hour. Also in China. Next slide, please. This is 83.3 tons per hour NVR. Quite big. Next slide, please. Okay, so after NVR process, we get the salt. Usually two types of salt: sodium sulfate, sodium chloride. So this picture shows you the recovered salt of sodium sulfate. Next slide, please. Okay, you can see the color is very white. Its purity very high, more than 98%. So it's industrial grade. The salt is recovered. Next slide, please. Okay, now let's take a look at the zero liquid discharge. We show you the 3D model of a plant. Like yesterday we have the sun. Today we have no sun. Never mind. Yeah. So this is the crystallizer. Okay, and evaporator. We go the heat exchanger, and this is the circulation pump. Yeah. So usually we make it a modular. So this is the NVR modular, and this post-treatment modular. And when the system in operation, usually we have this pre-treatment for the pre-treatment for the wastewater. So neutralization, activated carbon, or this. Yeah. So after that, we go to the filter press to filter off all this the particles. Yeah. Then go to the tank. Then you inject it to the buffer tank, and from the buffer tank, the water is pre-treated, pre-treatment, preheat. Then after preheat, then go to the NVR process. Then the circulation in the system, you can see there are two heat exchangers. Then after heat exchanger evaporation, and the red color is the steam. So the steam have the liquid gas separation. After separation, then the steam go to the compressor. Then after compress, the steam has a higher temperature and a higher pressure. Then the steam is reused in these two heat exchangers. So the non-condensed material as the heat also is recovered, then collected. So just now we mentioned that the preheat, the heat is recovered. Then the concentrated material is in the crystallize and the decanter. I decanter to separate the liquid and the salt. So the salt is recovered and collected as a product. Then the mother solution go to the tank and go to the system again, Nvr again. Yeah. Sometimes if we have a high COD, then this mother tank, mother solution should be treated. Yeah. So after evaporation, then go to the post-treatment. The post-treatment sometimes also need the chemicals and the AOP or this can be applied to remove the small amount of chemicals. Sometimes if volatile organic involved, then the volatile organic involved, then you have blowed out. So sometimes we also use micro-electrolysis in this way. Then after micro-electrolysis, then remove the solid by the filter press. Then only after detoxifying of the wastewater, then we pump the wastewater, the evaporated water into the biological process. So this is a simple 3D process for the treatment. Next slide, please. Okay, now we go to the conclusion part, and this is integrate the hazardous waste management center. This is the plan we have done for hazardous waste management company in China, and we hope that we can have the same system can be built in Singapore. Can you hear me? Jasmanda? Hello?
Yes, we can hear you, Dr. Yang.
Can hear me? Okay, yeah, because somebody said cannot hear me. Yeah. Okay, so in this in this way, with this three parts in this center. First part is the pre-treatment of wastewater, evaporation, stripping column, physical, chemical treatment, crystallization, all this. So the residue sent for the insertion system on the right side. Yeah. So the inserter itself will generate the wastewater, then go to the biological treatment at the bottom. Then after evaporation, the wastewater can go to the biological treatment also. Then from the pre-treatment on the left side, sometimes we get the recovered salt, and sometimes the solid residue cannot be recovered, cannot be inserted. Then we go for the landfill at the left side, left bottom side. Yeah. Then the biological treatment, we also can collect the different kind of wastewater from the customer. Because in this hazardous waste has to collect most of the chemical wastewater. So it's good to collect some kind of food wastewater, for example, to co-digest together. So in order to meet the discharge limit. So this is the whole integrated hazardous waste management center the concept we developed for a China company. Yeah. Next slide, please. Okay, these are our customers in China, Beijing Capital City, and in Singapore, Eco, Cremo, NSL, Malaysia, Global Cycle, Preference. All these companies are the waste management company. Next slide, please. Okay, these are the pharmaceutical company, majority in China, and most of the companies set up by the overseas, so-called overseas PhD from Europe, from USA. So they invest in China, and most of their product export to outside. For example, for GSK or this, they produce the intermediate. So that's why they're very cautious about the environment. So we work with most of these companies. Then the petrochemical, next is a local company, and the chemical logistic is Costco. We built the wastewater treatment plant for them, also operated for them in Zhangjiagang, near Shanghai. They have the container washing, tank washing, ISO tank washing, and the drum washing the wastewater. Then the sludge insertion, we involved the 800 Super local company, did the PUB sludge insertion plant. Yeah. Next slide, please. Okay, these are the semiconductor companies, Global Cycle or this, and other companies. This is my contact. Yeah, welcome you to contact me if you have anything to discuss, and collaboration. Very welcome. Thank you. That's all for my presentation today. I pass to Jasvinda. Hi, Jasvinda.
Okay.
Yeah.
A big thank you to Dr. Raymond Yang for the knowledge sharing on the insights and the effective pre-treatment ways on treating the pharmaceutical wastewater with biological method and patented technologies to treat in a more efficient and cost-effective way. Now we come to the Q&A segment. There are a couple of questions here. Okay, we have the first question here from Mr. Kishore Dobira. His question is 2 million investment cost for what capacity?
So for the capacity, for example, 5 cubic meter per hour Nvr process, and usually about 2 million to 4 million Singapore dollar, because all this the system in titanium. Yeah.
Okay. Thank you. Okay, the second question also from Mr. Kishore. He says, MVR also needs some steam apart from power.
Yeah, that's right. Yeah, for initial stage, you need to start up, and also for some seeding process, the compressor needs some steam. Yeah, you're right. Yeah.
Okay, we have the third question now from Mr. Jonathan Lee. His question is, what is the market potential and additional purification cost for the recovered VOC from the stripping pretreatment?
It's a very good question. Is that usually, for example, if the waste solvent is a single type, then this is very useful to be recovered. For example, the methanol or acetone. Then from the stripping column, we can get about 30 to 40%, from 1 to 5% concentration to about 30 to 50%. Then after that, we can refine again, go to the industrial grade. And another type of solvent is that if the solvent contains non-hazardous solvent, this solvent actually can be concentrated to be used as a thinner for as a paint thinner. Yeah.
Okay, thank you. Okay, we have one question from Mr. Antonius from HSL Constructor. Okay, you have two questions. The first question is, what is the estimated recovery of MVR process? And his second question is, you mentioned that the biological process use both MBBR and MBR. My question is whether the MBR is used to separate MLSS from treated water or mainly for filtration.
Okay, for the
first question.
For
the first question, yeah. So it's easy.
Yeah.
So okay. So first question is, what is the estimated recovery of MVR process?
Yeah, this one basically related to the salt and organic content. And based on our experience in Singapore market, the concentration level is about 20 to 1. That means 95% recovery. Yeah. So this is very interesting and significant. For example, if you have 30 tons of the wastewater, you go for initiation, right? Then we can concentrate only to 1 ton for insulation. This cost reduction is very interesting for customer. And for the MBBR and MBBR process, you are right. Basically, we have the filtration for the MBR, but still there's some sludge, active sludge left in the MBR. So it still can be considered as a conventional MBR. And of course, the MBBR, we have other functions, like we found that the ammonia reduction was very efficient.
Okay, thank you. Thank you, Dr. Raymond. Okay, we have the last question for today. It's also from Mr. Kishore. His question is, you mentioned MOC of MVR and stripping column. It's titanium, right?
Yeah, the MVR usually we use the titanium because the chloride involved. Yeah.
Okay. Okay, so we have come to the end of the Q&A segment. Once again, thank you, Dr. Raymond, on answering the questions.
Thank you.
And Pioneer Environmental Technology for co-organizing today's webinar. So here are some interesting events we have planned for you in May. Do look out for the EDM. So the very first one is on next 11th May, then 17th May, 19th May, 21st, and 27th. At the bottom is our web, where you can go to our website and click and can see our upcoming events. And if any further questions and any contact required, please contact me and I can forward you all the contact of Dr. Raymond Yang. Okay, now thank you everybody. Stay safe and we'll see you next time. Thank you. Bye.
Thank you.